Hello friends, in this session we will talk about Pulley constraint. Here constraint means some restriction or we are talking about fixed quantities like length of string, length of rod, etc. Now we will talk about some general configuration of pulley. So the first configuration is P1, that is pulley at rest. Means pulley is rotating but not moving with its position. Second is pulley is moving but one end of string is fixed. Means pulley is rotating as well as moving. In this case you can see that pulley is moving upward with acceleration A1. And third one is P3 means pulley is moving and both end of string hanged with weight. So here is the first case, pulley at rest. As we know, total length of string is fixed, means by 1 left portion length and by 2 right portion length. We can easily say that y1 plus y2 will be constant. In fact, we can also say that change in y1 plus change in y2 will be 0. On dividing this equation with dt, we will get derivative form of y1 and plus derivative form of y2, and that will be also 0. And this derivative form is nothing but the velocity of m1 and m2. So what is the logic of sign? Here, if y1 is decreasing, then we will put negative sign. Actually, rate is decreasing. And if y2 is increasing, then logically we will put positive sign. And if we again differentiate second equation, we will get double differentiative form of y1 and y2. And this is nothing but the acceleration of m1 and m2. And we can write it as minus a1 plus a2 equal to 0, and finally we will get a1 equal to a2. This is the constraint equation for acceleration, and v1 equal to v2, this is the constraint equation for velocity. But this is the lengthy process, so here I will introduce some simple concept. Means here I am introducing tricks to write directly these constraint equations. So here if we look left hand portion of the string, then upper end assumed to be fixed and lower end is moving, and it is decreasing length by 1 with acceleration a1. And if we look right portion of the string, then lower end is increasing length y2 with acceleration a2. So logically a1 is decreasing the length and a2 means length is being increased by a2. Then we will put positive for a2 and negative for a1, and we will get equation this minus a1 plus a2 equal to 0. And by using it we can directly write a1 equal to a2, and this is the constraint equation, and same can be done for the velocity. Second case is pulley is moving but one end of string is fixed. This case, so here on applying tricks, lower end is fixed and upper end is increasing the length with acceleration e1. And if we look right portion of the string, you can see that both end are moving. So here upper end is increasing the length with acceleration a1 and lower end is decreasing the length with acceleration a2. So logically for increasing we will put positive sign and for decreasing we will put negative sign. So here is the equation a1 plus a1 minus a2 equal to 0. And finally we will get a2 equal to 2a1. And same process can be done for the velocity, and we can easily get v2 equal to 2v1. This is the constraint equation for velocity. Third case, pulley is moving and both ends of string hanged with weight. In this case, you can see that pulley is rotating as well as moving upward direction with acceleration a. So again applying tricks on left portion, upper end is increasing length with acceleration a, and lower end decreasing length with a1. If we look right portion, then upper end increasing length with acceleration a, and lower end decreasing length with acceleration a2. So here is the equation: positive for a, negative for a1, positive for a, and negative for a2, and that will be equal to 0. And finally we will get constant equation for acceleration equal to a1 plus a2 divided by 2. And same process can be done for the velocity, and we will get v equal to v1 plus v2 divided by 2. So here we understood about the constant equation and how to write constant equation by using tricks. But here, how to use these constraint? So here's the question. This is the case, and the question is, find the acceleration of this string and two mass block system. So here the case is pulley is fixed, but pulley is rotating but not moving. So first of all, we will draw FVD of M1 and M2. So here is the tension T on M1, and this is the weight of M1, and this is tension on M2, and this is the weight of M2. According to constant equation, we know that A1 equal to A2 in this case, and I am considering it equal to A. And if we write force equation, means if we applying force law on M1 block, then we can write it as T minus M1G, means net force will be T minus M1G, and that is equal to M1 into A. Actually this is the mass and multiplied with acceleration of that mass. And again for the force, again applying force law on M2, then M2G minus T equal to M2A, means mass into acceleration of that mass. On adding equation first and second, we will get this relation, and on taking a common part, we will get this relation, and finally we will get A equal to M2 minus M1 divided by M2 plus M1 multiplied with G. Actually, this is the relation for the this mass and string system, and acceleration will be difference in two masses and divided by total mass, and whole expression multiplied with G, which is acceleration due to gravity. So by using constant equation, we can easily solve such type of the problems. I hope you understood it. So thank you.